So now since A is given -1 revolution, that is anticlockwise sense, so what will be the angular velocity of P? Since A is moving in this direction, P will also move along this. As you can see, if A is moving in this direction, the direction of movement of P is same as A. So P also moves anticlockwise, and the velocity ratio is from this relation omega A by omega P is equal to Tp by Ta. So omega P will be Ta by Tp. Omega P will be Ta by Tp times omega of A. So omega is 1 revolution minus 1 revolution. So the revolution for P will be Ta by Tp, and in the same sense as what is omega is there. Omega A is minus negative sense, so it will also be negative Ta by Tp. Then what is the movement of sun here? So since P is rotating in anti-clockwise fashion, the sun will move in clockwise fashion. Remember, the leg is fixed. So the direction of sun movement will be positive, and the ratio will be omega A is equal omega S. Omega S is equal to omega P into Tp by Ts from this identity here. And then you know omega P, you substitute the value of omega P is equal to Ta by Tp. So Tp and Tp will get cancelled out. I'll just write it here. Omega S is equal to omega P is Ta by Tp multiplied by Tp by Ts multiplied by omega A. So Tp will get cancelled. So we have omega S is equal to Ta by Ts omega A. So we'll put the value for one revolution of A, we'll have Ta by Ts revolution of sun, Ta by Ts, and the sense will be positive because you can see here it is clockwise. And the third step now, the third step is to add step 1 and 2. So we get +1 revolution for the leg, 0 revolution for the annulus, so we wanted to keep the annulus fixed. 1 minus Ta by Tp revolution of the planet, and 1 plus Ta by Ts revolution of the sun. So now we can get the ratio of all the velocities in the system when the annulus is fixed. So if you want omega L by omega P, let's say, for one revolution of leg, how much the planet here moves, you can get it as +1 is moment of L divided by moment of P, the planetary gear, that is Ta by Tp. Similarly, if you want omega L by omega S, the ratio of leg and the sun velocity, remember in this case, when the annulus is fixed, the sun is rotating in a clockwise fashion or anti-clockwise fashion depending on the velocity, angular velocity of the leg. So all these three, remember, planet, sun and leg are moving. And omega L by omega S you can define as +1 divided by 1 plus Ta by Ts, and the direction of motion you can find from this geometry that sun and planet are opposite sense. For finding the relative rotation sense for the leg and the planet, you can see this equation. From this figure, you can see that the annulus is much bigger than the planet, and it has to be bigger than the planet, otherwise planet will not come inside the annulus. So number of teeth on A will be greater than number of teeth on P. So hence Ta by Tp will be greater than 1. So this quantity here 1 by Ta minus Tp will be negative, and hence omega L by omega P will be a negative quantity. So hence the number the sense of rotation of L will be opposite to what the sense of rotation of P. If P is moving anti-clockwise, L will rotate clockwise. This is an important observation here. direction of rotation of L will be same as S. The direction of rotation of planet with respect to Sun is anyway negative, because you can see here, if everything is fixed, Sun is rotating clockwise, planet will rotate anti-clockwise. So this is a general derivation when annulus is fixed and all the three components, the leg, the Sun and the planet, are moving. There is another method for determining the ratio of the speed of shaft of the of leg and with respect to the speed of either planet or the annulus. So in this method, you consider that the annulus is moving at omega A, the Sun is moving at omega S, the leg is moving at omega L, and the planet is moving at omega P. So you consider that we will, if we start in this configuration, if we start to move all gears, the entire configuration about the center is same for all, as you can see from this figure, with a speed minus omega L. Then if you are seeing from that frame of reference, so in minus omega L frame of reference, the speed of various components in this epicyclic chain will be the A, which is annulus, will be omega A minus omega L. The Sun will be omega S minus omega L. The planet will be omega P minus omega L, and the leg will be omega L minus omega L, that is 0. So this will come as a case where the leg is fixed. So if the leg is fixed, it is pretty much straightforward to determine the velocity ratio that you saw earlier. In that case, the omega of Sun by omega of planet will be Tp by Ts, and similarly for S, and also you can determine. But consider in this case, the angular speed of the annulus is not omega A but omega A minus omega L. So we know the train value, the gear ratio or train value is equal to, the gear ratio is equal to speed of driver divided by speed of driver by driven. So if the leg is fixed, let's say Sun is rotating at omega S and annulus is driven, then this will be equal to omega S by omega A, that will be equal to Ta by Ts. So this value will be fixed if leg is fixed. So we have derived a condition where the leg is supposed to be fixed, that is omega L is 0, because we are rotating the entire thing by minus omega L. In that frame of reference, the angular speed is this much. So in that frame of reference, the gear ratio will remain same even if the leg is fixed or not. So in that case, we'll have in speed of the driver, that is omega S minus omega L, divided by speed of the driven, that is omega A minus omega L, equal to Ta by Ts. So from this equation also, we can get the velocity ratio for the epicyclic chain. And similarly for the planet, it will be omega P by omega L divided by omega S, or endless, which anyone can be driver, anyone can be driven. This is a general method, is equal to Ts by Tp. So Ts by Tp is the gear ratio in the case the leg is fixed. And you can determine the gear ratio for the case where leg is fixed, then determine the angular velocity in the minus omega L frame of reference. And since the gear ratio will remain same like that, you can form the equation for angular velocities. And since you know Ta by Ts, you can solve these things. So normally one of the things will be given, like omega L and omega S will be given, then you have to solve for omega A here. So now we will consider some numerical related to this subject. So first numerical is on a simple gear train. So simple gear train is given in this form. Like there are a lot of gears. This is meshing with this. then this is meshing with this. So number of teeth of all the gears are given. Let's say this is 10, this is 50, this is 70, this is 80, this is 10, this is 60, and this is 20. So number of teeth is given, and it is asked to find the gear ratio or velocity ratio. So we know that the gear ratio is equal to number of teeth, like the speed of driver, omega driver by omega driven. So from in this identity, you can see that the number of teeth on the intermediate gears doesn't matter. So if this is a final driven, let's say teeth B is driven, and this is a driver. Let's say A is the driver. So we only need to consider the number of teeth of driven and driver to find the gear ratio. The intermediate number doesn't matter. So there is no need to get confused from the number of such a complex chain and so many number of teeth are given. We just have to consider the input and the output. So driven has 20 teeth and the driver sorry here. So driver teeth driven by teeth driver is having 10 teeth. So the gear ratio is 2. So next we'll consider an example on the compound gear train. So in compound gear trains, the two gears are connected by a common shaft. So let's say this is the gear train, gears connected by common shaft, and then we have one gear meshing here, that is the input. So this is input, and then we have one gear, that is output. And this is the special case of compound gear train where the input and the output shafts are along the same axis. So this is called a reverted compound gear train, if you remember. So it means input and output are on same axis. So here in this problem, it is provided that number of teeth on pinions, both the pinions are same. So if you recall our definition, pinion is the smaller gear. So here gear A, and let's say this is gear X, this is gear Y, intermediate gears, and this is output gear B. So that means A teeth, number of teeth on A and number of teeth on Y are same, and these are the two pinions. A and Y are small, and hence they are pinions. And the second condition that is provided is that module of all gears are same. So in a gear train, we had an initial definition that the module of all gears in a gear train should be same, but in a compound gear train, it is not necessary. So, like A and X will anyway have same module, and Y and B will also have same module. But in this case, the special condition given is that module of all gears is same. Now we will take up another numerical example, this time related to the epicyclic gear train. So I'll draw a epicyclic chain here. We have a gear A, which is the sun gear. It meshes with gear C. This is a planet gear, and the C is enclosed inside a annulus. So this is the annulus, and A and C are connected by the leg. The standard epicyclic train. And in this case, they have given a special combination of epicyclic gear train as well as compound train. So the gear C, which is the planet of the first train, and this is gear A, this is sun of the first train. The gear C is made to have a compound gearing with gear B. So gear C and B are on same axis, but the gear B is smaller. Now the gear B is made to mesh with another internal teeth annulus, and that is termed as gear D, the internal teeth. And where C is rotating on this annulus gear. This annulus gear is termed as E. So you can see there are a lot of gears here, and then we have the leg also, the epicyclic chain. The leg is termed as F, which is arm. These are the gears. Now, in this problem, we are given some limited information. This is a complex problem, so you have to form the equations for solving that. So, gears A, C, and C have 18, 45, and 21 teeth respectively. So, number of teeth on 3 gears are given, and all gears have same module and pitch. Since module is same, pitch will anyway be same. And speed of rotation of 2 gears is given, that is NA, the number of revolution per minute of gear A is equal to 90 RPM counterclockwise, counterclockwise, and ND, the angular speed of B is given in RPM as 450 RPM clockwise. So, with this limited information, the question asked is that find the speed, rotational speed and direction of arm F and gear P. So we have to approach this problem in a systematic way, and it is not necessary to approach the problem in terms of angular velocity, since angular velocity is 2 pi n by 60. So 2 pi by 60 is anyway constant. We are working in terms of ratios, so we can work in terms of n as well. Now we have to solve this problem. We are provided by with these values. TA is equal to 18, TB is equal to 45, TC is equal to 21. Angular speed of A is minus 90 because it's counterclockwise. Now we are taking clockwise positive. Angular speed of B is 450 RPM. Clockwise is suggested for positive. Now for solving this problem, if you keep the arm fixed, then the problem becomes pretty much straightforward. This becomes like any other compound gear train. A is driving C, and C and B are on same axis. B is driving D. So you can treat A as the input and D as the output. And E is having its own angular velocity depending on the angular velocity of C, but it is not connected to any of the other elements. So A becomes input and D is output, and becomes a simple compound chain. So we'll determine the gear ratio for that case first. For determining the gear ratio, considering A as input, D as output, and F arm is fixed, we have to know the number of teeth on gear D. We know A, B, and C. We don't know on D. So this we will get from the radius identity. So since module is same, the number of teeth are proportional to radius. This is RA and this is RC. This much distance is RC, and then we have RB. So and this distance from center of A to this point is equal to RD. So this is RB, this is RC. So you can see RA plus RC plus RB is equal to RD. Hence, so RA plus RB plus RC is equal to RD, since radius is directly proportional to number of teeth because module is same. So hence TA plus TB plus TC will be equal to TD, and since the TA, TB, TC you know 18, 45, 21 TD, so hence TD will be equal to 84 teeth on gear D. So hence the velocity ratio, that is equal to driver by angular speed of driver, and that will be equal to number of teeth on the driven by driver. So driven is D, so TD by TA, and since it's a compound, it is a compound chain, so TA is driving C and B are on same axis. So you have to multiply the intermediate number of teeth also. That will also matter. So we will get here TB and here TC. This is a very straightforward derivation. You can do it for yourself. So velocity ratio is this one. So if the leg is fixed, say let's say the leg is having some rotational velocity and F. So F is the arm, and so we have to consider minus NF frame of reference. We will rotate everything minus NF. Then this is the second method for determining the velocity, angular velocity in a cyclic change that I described a few minutes back. So minus NF frame of reference, we have the angular velocity of F, but since we are moving with minus NF along with the train, in that reference the leg will appear to be fixed and the velocity ratio will remain same. With minus NF frame of reference, the velocity ratio will be speed on driver. So driver is NA minus NF. The speed will be that reference frame. Speed of A will be NA minus NF, and the speed of D will be ND minus NF. And this will be equal to the velocity ratio. That will determine that TD into TB by TA into TC. So in this equation we know TD, TB, TA, TC. We know NA and ND. So these are provided quantities. So we can calculate NF. If you substitute the values, you will get the equation equal to 45 into 84, that is TD into TB, divided by 18 into 21 equal to NA. NA is minus 90 minus NF, divided by 450, that is ND minus NF. Now in this case we have to determine the velocity ratio, but we have to assign a sign to it also. We know from the given condition that NA is minus 90 and ND is plus 450. So the direction of rotation of input and output is negative. So hence the velocity ratio will also be negative here. You have to consider this sign convention. You should pay attention, otherwise you get wrong result. So the minus sign also should come here. If you simplify this equation and solve for NF, you will get NF is equal to 400.9, and you will get a positive value. So it will be clockwise. So we have found the answer for part 1. We found velocity of R. Now for the second part, the angular velocity of E is asked. For that we have to look at our diagram again. Now we don't know the number of teeth on E, so first we have to find that. So if we have to consider a radius RE, so RV will be equal to RA plus RB and then again RB, so 2RB. So RA plus 2RB. You can see much clearly here. This is the diameter of B, that is 2RB, and this is radius of A, RA, and this will be equal to the radius of E. So R equal to RA plus 2RB. Since number R is proportional to teeth, module is same. So number of teeth on E is equal to TA plus 2TB. Substituting the value, 18 plus 2 into 45 is equal to TE is equal to 108 teeth. So now again we will follow the same procedure. We will consider A as input and E as output, and first determine the velocity ratio. So the velocity ratio will be equal to, in this case, since now the leg is fixed, in minus NF frame of reference. So this is the power of this formula, that we can determine the velocity ratio by number of teeth very simply. So here you can see A is meshing with C, and C is directly meshing with E. So here you don't have any compound gear train, you have a simple gear train. So it will just depend on the number of teeth on the driven, that is TE, divided by number of teeth on the driver. So TE by TA. What about the sign? If you consider A as moving anti-clockwise in this direction, then C will move clockwise. C moves clockwise, then E also moves clockwise. So directions are opposite. So hence the velocity ratio will be minus TE by TA. Now the velocity ratio from the angular speed in minus NF frame of reference will be equal to NA minus NF, that is speed of the driver, divided by speed of driven, that is NE minus NF. And this will be equal to the velocity ratio, that is minus TE by TA, that we saw here. Substituting the value in this equation, we'll get minus 90 minus 400.9 that we got just now, divided by NE test to be determined, minus 400.9 is equal to minus 18 minus 1 sorry, minus 180 divided by 108 minus 108 divided by 18. So simplifying this equation, we'll get the final solution as NE is equal to 482.7 RPM, and this is positive value, so it will be clockwise positive. So this is the answer for part 2. If you just look at the values of the speeds, you can see here this 482 and then 400.9, input is 90. So by use of such complex epicyclic and compound gear train, you can get very typical values of gear ratio. So that is the power of such trains, and they are used in some special applications, particularly in wall clocks, the mechanical wall clocks. You want to get some specific gear ratio in some confined space, which is not necessary for a compound epicyclic chain. So this chain can have a different module, this chain can have a different module, but this is given in this present problem. And the final condition that is given in the problem is that the gear ratio is equal to 9. So that means omega A by omega B is equal to 9. The driver shaft by the driven shaft. Now question asked is that if TA, number of teeth on pinions, equal to Ty, that is same, that is provided, is equal to 10, what is number of teeth on the two wheels? That means Tx and Tb, the bigger gears in this chain. What is Tx and Tb? This is the question asked. We will go with the solution. So first we will write down the formula for the gear ratio of the compound chain. So if you see from this diagram, it will be the omega x by omega A will be Ta by Tx, and then we have y and b, and then we multiply them together. The formula is pretty much straightforward. You can look it for yourself. So Tx by Ta multiplied by Tb by Ty will be the gear ratio, velocity ratio. This is provided as equal to 9. So this is our first equation. Now in this equation we know Ta and Ty that are equal to 10, but we don't know the value of Tx and Tb. So for that we have to find another equation, because we have two variables and only one equation. So we have to find another equation. So second equation comes by geometry of the gear train. So from the geometry of the gear train, you can see that since the input and output are on the same axis, if you draw a center line here, so now you can see that the distance between the shafts of the compound train is same. So radius of A, Ra, plus radius of gear B, gear X, Rx, will be equal to radius of gear Y plus radius of gear B. So this is a second identity, because it's a reverted gear chain, input and output lie on same axis. So Ra plus Rx is equal to Ry plus Rb. Now since module is same, so radius is proportional to number of teeth, because module is nothing but diameter by teeth. Diameter is radius by 2, so radius, so R is equal to 2mt. Since module and 2 are constants, R is proportional to T. So if you put here and take 2m outside common, then we get Ta plus Tx is equal to 2m Ty plus Tb. Now we consider 2m here, and you know that Tx is equal to Ty, Ta is equal to Ty, that is equal to 10 provided here. So Ta and Ty also get cancelled. So from this equation you get Tx is equal to Tb. So this is an important identity that we have got here. This you can substitute back in our first equation. So you put Tx equal to Tb, then you get Tb whole square divided by, you put Ty is equal to Ta, or Ta is equal to Ty, then you get Ta whole square is equal to 9. So from this identity you get Tb by Ta is equal to 3. Square root of 9 is 3. And from here you get Tb will be 3 times Ta, and Ta is provided as 10. So hence Tb is equal to 30, and since Tx is equal to Tb, so Tx is equal to Tb is equal to 30. So in GATE examination, you'll find normally the problem which doesn't involve too much of numerical, just the logical understanding. So here the condition provided are that the pinions are of same size and the speed ratio, and the gear is reverted. So the input and output are same axis. From that itself, you can determine the number of teeth.